Hi everyone. Today we have another important topic in Pandas series that is about how we can process time series using Pandas functionality. Time series is an important form of structured data that we commonly see in many fields including finance and physics. Anything that we can measure or observe at many points in time, for example, when we place sensors on a building or on the ground to monitor, for example, earthquake vibrations, that will generate time series data. Here in this example, we see daily temperature data for 2 weeks and it starts from February 1st, 2025 to February 15, 2025. And we see four different curves: maximum hourly mean, mean of min max, and minimum values of temperature within this time period. In Python, we have a very strong functionality, and that's the datetime module. And from datetime, we can import datetime and time delta. And for example, we can see what time is it right now, and that is by using now method from datetime. And if we see, today is February 16, 2025, and here in Eastern Time it's 1:45 p.m. Now we could also extract component or pieces of information. For example, what year was that, what month was that, what day, hour, minute or second. We could do so using now.year attribute and now.month attribute and so on. And we could also compute the temporal differences, that is the time delta, between two datetime objects. Here we have a datetime object and we are subtracting another datetime object from it. That gives us the temporal difference between these two objects. Again, we can see the attributes days or seconds. And here we see that in seconds we have 28,890 seconds and 1,830 days. Now if we want to verify if this second calculation is correct, we could write some lambda functions here. For example, hours to seconds, we can write this lambda function that multiplies the input by 3600 and that will convert hours to seconds, and similarly we could convert minutes to second by multiply a minute by 60 seconds. Then we write another function that is hour minute second. Once passed, we convert back the number of seconds for this specific hour minute second value. And here we are returning hours to second and we're converting hours to seconds, then minutes to second and seconds as they were included in the input, and we sum them up. That will give us the total number of seconds. Now if we want to test this function, we could try this by inputting the hour, minute and seconds, and we could confirm that we get the same number of seconds, that are 28,890 seconds. Now we have a timestamp and we assign this to variable start, and then we could use the time delta function and specify the number of days that we want to add to this start timestamp. Here we can see the date has been changed from 25th of June to 7th of July. We can also include hours along with days in the time delta function. And now we see the hour value has changed to 3 instead of 1. Similarly, we could include minutes in the time delta function as well. And now since we added 60 minutes, that is 1 hour, we see the hour value increased by 1 hour. Next, we will see how to convert between string and date time. Here we have another timestamp. We could convert this timestamp to a string by simply wrapping it in a string, and we see a nicely formatted string. Then we could use the method string from time and provide a format in which we want our datetime string to be, and we can see that we get the same results but this time with the required format. We could change this format by using any of these notations here. And the last two lines, if you see, there are shortcuts for example, year, month, day, shortcut for month, day, year formats. Now we will see how we could use these shortcuts to convert a timestamp into a datetime string with the required format. And here we could see that we have the desired formats for the same timestamp. So this is a very powerful utility and we should use it when dealing with timestamps data. Now we will see how we could see a string and convert it back to date time. For that, we will be using parse from dateutil.parser. And now, within this parse method, we provide a date string and it converts it into a datetime object. Again, parse can work on many different formats. So here we could see that parse has successfully converted it to datetime object. Now, when we see dates like this, it's sometimes confusing whether it's month, day, or year, month, or day. We could specify is day first is equal to true, and then parse will be able to read it properly, as we can see here. Now, this was all about Python functionality. Now we move on to the topic that we wanted to discuss, that how does Pandas deal with the time series data and what functionality does it offer. For that, we will import the packages pandas as pd, numpy as np. Now we have a list of date strings, and then as we saw in the previous videos, we could use pandas to datetime method to convert these date strings to datetime objects. A basic kind of time series object in pandas is a series indexed by timestamps. Here we are creating a list of datetime objects for different years between 2011 and 2016, and then we are using numpy's random.rand. We generate 6 values, and then as an index to the series we are providing this list of dates. That will generate this time series which has the index as the datetime objects and some random values corresponding to these dates. We could see the index of this series using ts.index, and that is a datetime index. Here we could see the data type as well. We could see the every second value in this time series and then add every second value in the time series to its current value. Here we can see that the every second value is finite, whereas the rest is none or missing. This is because we tried to add this time series which only has 3 values into our original time series. Now Pandas stores timestamps using NumPy's datetime64 data type at the nanosecond resolution. We could check that using ts.index.dtype, and we could see the nanosecond value here. The good thing about this date time formatting in Pandas is that we don't have to follow this format. We could query this time series using any of these date time format. Here we are trying to access January 1st, 2013, and we get the corresponding value which is 0.88688 here. We could also get the same value using this date time format. This is very handy when dealing with time series data. Next, we could use Pandas dateRange function to generate a range of equally spaced time points with the given frequency, that is start and periods and time zone, and we could do so using this Pandas dateRange method, and we could provide a start date, we could provide an end date, and then we could also provide a frequency. So here the frequency is daily. It will start generating time series for every single day. Let's see how it works. And here we could see that we have January 5th, January 6th, 7th, 8th, and until 12th of January. And the frequency is daily here. Now we could also provide periods, so that will be the daily period. So if we run this, we could see that we have January 1st, 2nd, 3rd, and it goes up to 9 because these are 9 periods. And again, the frequency is by default daily. We could change the frequency, let's say to month start here. We want the 6 periods, so it will go through every single month and give us the dates of the month start for each single month. Let's see how this works. And now we could see that we have January 1st, February 1st, March 1st, and until June 1st. We could also say month end and rerun this command, and now we have the end dates of the month instead in the list. Again, we could also say year start and give the period to 6. This time it will give us 6 different years. So 2008, 9, 10, 11, and up to 2013. And here we could see that frequency is year start and January. So that's the first month. Now we could also provide time zones here. So here I'm writing Asia, Tokyo and providing periods 5, and that will automatically give us the date time objects in this time zone. And we could see now the data type is datetime object in nanosecond and with the time zone Asia, Tokyo. We could also say whether which value to include from the start and end. So in this case, we are saying inclusive left. So in this case, we will include this start value, but we won't include this end value here. Let's run this. And now we could see we have 3 values, January 1st, January 2nd, and January 3rd, but it does not include January 4th here. And frequency is daily. Similarly, we could say inclusive right. In this case, we will ignore the first value while include the last value. So here it starts from January 2nd and goes to January 4th, which is the end value. Again, all of this is very simple and very easy. It becomes very useful when dealing with time series data. Now, let's say if we have a long time series, so here we have Pandas series. Now we have generated 500 random values, and in this case, we have a date range as an index, and it starts from 2005, and periods are 500. And remember, by default, the frequency is daily. If we run this and look at our longer time series, we can see there is daily frequency. It starts from January 2005 and it goes until 15th of May 2006. Now it's very easy to filter out dates for a specific year. We just need to provide the year and then we could filter out the dates only for 2006. It's a very simple utility that lets us filter the data very easily and efficiently using Pandas. And now if we want to add the month along with the year, we could also extract data only for the month of May for year 2006. Now we could see that we only have data from the month of May and for the year 2006. Similarly, we could provide any other date as well, and we could extract a single value. We could also do slicing from one date to another, and here it starts from January 5th and it goes to 5th of April. We could also truncate a series. For example, we don't want anything beyond 5th of April in 2005. We could do so using truncate method, and it will stop giving us the information beyond this date value. Now we are creating another time series with these dates, and we could see there are duplicate dates, and we will see how we could deal with the duplicates or identify these duplicate dates. We could use pandas index is unique attribute, and it is false, which indicates there are duplicate values in the index. And we could group by and provide level equal to 0, and then we count it and see how many duplicates are there for a single datetime object. So very handy utility again. Let's now see another useful functionality when dealing with time series. Oftentimes we need to shift the data backward or forward through time. Let's use the duplicate time series here. We have 5 values. Now if we use the shift method, we could see that now the values have been shifted upward and the last 2 values are showing missing values. If we change the sign of the shift, now the values are shifted downwards and we see the top 2 values are missing. Because naive shifts like above leave the index unmodified, some data is discarded. Thus, if the frequency is known, for example whether it's daily or monthly, it can be passed to shift to advanced timestamps instead of simply shifting the data. So here we are shifting the data by 2 samples, and now we are providing the frequency in the data as well. Now we could see that we have correctly shifted the indices, but the data is still there. Again, working with time zone is generally considered one of the most unpleasant parts of time series manipulations. As a result, many time series users choose to work with time series in Coordinated Universal Time or UTC, and time zones are expressed as offsets from UTC. For example, New York is 4 hours behind UTC during daylight saving time and 5 hours behind the rest of the year. So let's see how we could work with time zones. We use PyTZ package, and then we could see if we use PyTZ common time zones, it lists all the time zones available in this package, and here we are listing the first 5 in the list, and we could see different time zones. So to get a time zone object, we need to do PyTZ time zone and then provide the name of the time zone. And when we create the date range object, we provide the date, periods, frequency, and now we are also specifying the time zone, which is UTC in this case. And we could see that the data type is now nanosecond and UTC. We could also convert from naive to localized by the TZ localize method. So we have a time series, and if we use TZ localize and provide a time zone, time series time zone gets updated. Again, we could use the TZ convert to convert from one time zone to another, and this time we have the America Toronto time zone. Time zone aware objects internally store a UTC timestamp value as nanoseconds since the Unix epoch, which is January 1st, 1970. This UTC value is invariant between different time zone conversions. Now, when we deal with time series data, we often perform resampling and frequency conversion. Resampling refers to the process of converting a time series from one frequency to another. Aggregating higher frequency data to lower frequency is called downsampling, while converting lower frequency to higher frequency is called upsampling. So let's see how this works. Here we have the date range object, and we use this to generate a time series. Now we could resample it to the start of each month, and we could calculate the mean value per month from the given data. We could also provide a slice or range of different dates, and we could extract the mean values. For downsampling, we can aggregate the data to a regular lower frequency. So here we have another date range object, and here I am using T for the minute, so it's recommending me to use minute instead. So let's change that, and now we have the minute frequency, and now we use that as an index to this time series. We could resample the data by 5-minute interval, and we could say close is equal to right, and then sum the data within. So these are the values. We could also calculate the sum of the first 5 values. And there is also a open high low close resampling. In finance, it's a popular way to aggregate a time series to compute 4 values for each bucket, and that is in the resampling bucket when we are binning the data and computing the statistics. The first is the open, last close, maximum high, and minimal low values. So these are all provided in the open, high, low, close resampling. So let's run this resample on the time series, and we have all 4 values open, high, low, close for these timestamps. Now there is also some other sliding window operations that we could do on the time series. For example, moving average filter to smoothen the time series. We could do so. For example, we have this weatherstat CSV data here. So we load this data using read CSV method, and there are many columns. We have the date column, max temperature, and so on. We could check the data type for the date. It's an object, so dates are in strings. We could use the pandas to datetime method to convert these strings to datetime objects. And now if we look at the data type, it's in nanoseconds, so it's a datetime object. We could check the head again. Now we could use this date column and set it as the index of this data frame, and we do so using set index method. And then we have this max temperature, so we only work with the max temperature column, and then we plot the max temperature series, and then we apply a moving average window which has the frequency of 5 days, and then we compute the mean over 5 days and then plot it as well. Now we can see that the blue curve was the original time series, and this orange curve is the result of the moving average filter or the sliding window operation on the time series. So you could see all of this functionality can be pretty handy or useful when working with the time series data. So please try it, practice it, and get familiar with more functionality in Pandas to deal with time series. That's all for today's video. Thanks for watching. Don't forget to subscribe to my channel and see you all in the next video.